Hey everyone, this is your week 5 R script for those of you that are doing R. What we're going to do is we're going to take a really quick look in the next 2 weeks at text mining using R. We've talked probably over the weeks, months, whatever, that data that we have been looking at in the text mining class and then in this class all comes in a nice, clean format. The biggest challenge we ever had was when we were missing data and some of the R functions had to be changed so we could account for missing data. But the actual truth is that structured, neatly formatted data makes up a very small part of what we're dealing with in data mining these days. And so we're going to take a look at some of the processes. It's just going to be a very quick look, and I invite you to look deeper on your own. Some of the processes that can be used in processing text. And where we might do this is if we were creating, for example, a spam filter, where we might be able to identify spam emails based on some of the content that they have, or we're trying to just basically do some classification where we're looking at different text messages and the like to be able to sort of determine what class they belong to or something like that. So the first thing I'd like you to do is I'd like you to read chapter 20 in the textbook up until the middle of page 487. There's a section of 487 on performance, absence versus frequency. Might be nice to read through that little paragraph there. But if you read through this section, what I've basically done is I've taken all of the little snippets of code that they put into chapter 20 and I put them into a single script. And I will post that script, I will have it posted probably by the time you see this, into the module for module 5 for the class. I'm going to run through real quick what they're doing, and it's pretty straightforward in the sections that they've included, but I'll sort of offer some insights into kind of the whole process of text mining. So we'll start at the top of the script, and I'll make this script bigger. And we're going to use 2 new libraries. One of them is TM for text mining, and the other one is Snowball C. I have no idea why it's called Snowball C, but it serves a particular function of removing stuff from a list of tokens that we don't want. In other words, to pare down a list of tokens. Now let's talk about terms in text mining. There are a few that they talk about in the book. Well, they talk about all of them actually in the book. There's documents, and documents we might think of as documents as in a large document, or document can be something as small as a sentence. And so we treat each one differently. And when we parse through and actually look at the words that are in a document, we would be looking either at a single sentence or we would be looking at an entire document. There's something called a corpus. A corpus is a collection of documents. So a corpus could be a collection of sentences or a collection of long documents. But they're generally all in the same format, and we can deal with them all as a collection of something that looks fairly similar. The other term that they don't really define, but they talk about in the book, is token. And there's a process called tokenization. And it's something that we use when we want to look through a collection of documents that are located or stored as a corpus, and we want to identify the tokens. A token in a document is something that is truly unique. It is something that could really be kind of different than every other token. So words that wouldn't really be tokens are small articles like an or the, or a word like I or we or something like that. Those aren't really tokens because they occur in natural language so much that they wouldn't make a document stand out if we identified the number of instances that they occurred in a particular document. So what we're really looking for when we're looking for tokens is we're looking for words that really are different. So if you had, if you wanted to do a sentence like, I have decided to do my specialization in data and analytics. The I, the have, the my, all those not tokens because they're not really terribly useful. They don't really tell you anything about what's in that particular sentence or document. But the word specialization, data, analytics, those things are tokens in the sense that they help to define kind of really the meaning of that particular document or sentence. And I think you'll get a feel for it as we go. The process of tokenization is the process of converting text input to a list of tokens. And then what we do is we really kind of don't care about the order of the tokens, and we really don't care about, we do care about the frequency, but what we'll do is once we reduce everything to a list of tokens, we will take an approach called bag of words. And bag of words is where we basically take a corpus or a collection of documents, we reduce them down to usable tokens, and then we use the bag of words approach. What we can then do, and we'll look at this more next week, is once we've identified a list of tokens in a bag of words, we can then apply that filter to a much larger set of documents. Maybe it's a 150,000 emails or something like that. And we could start to see what's happening. And imagine that we're looking at a customer service database. And in the customer service database, we're getting comments from customers about how happy they were with our company's service. And so we do a tokenization process to create a bag of words. These are unique tokens. And then we count the number of times each token shows up in our customer service database. We can start to get a feel for what's going on across our customer base without really having to read all of the thousands of customer comments or customer complaints that we might see. So we start to get a kind of a real quick check. This is something also could be used in in marketing. It could be used. It's probably most useful in like I said, filtering out spam email messages, and also used in professions where you have to process a huge number of documents, such as attorneys who have to look through pages and pages and pages of documents in order to identify what's essentially tokens that are meaningful. So that's just kind of a little bit of the terminology. So anyway, let's start on the script. The first thing we're going to do is we're going to load up 2 new packages. I already talked to you a little bit about TM and Snowball. Snowball gets loaded later, but you're going to have to install those packages because the script doesn't do it for you. The first thing we do is we parse through simple sentences. So I have created, this is all from the textbook, so there's nothing magical about this. But I've put into the script the 3 sentences that they put into a vector. So of course, as you know, we use the C function to create a vector, and this is a vector of 3 sentences, or 3 strings of sentences. And that all gets dropped into a vector called text. The next thing we do is we convert that to a corpus, basically because it's 3 sentences that look basically the same, so we create a corpus, which is basically a different format of it. And that's done using the corpus command, which is part of the TM package. What we have to also specify, though, is that the source is a vector, so it knows to look for the starts and stops of the 3 elements that are actually in the vector. So that's where the vector source comes in. Text is what we created when we loaded in the sentences. And we're going to drop all that into a variable called corp. Then we pull down to computing the term frequency. And so TDM is the distribution. It's a variable, basically. And it's going to be where we're going to actually store the distribution of the terms and how frequently they show up. That's done using term document matrix, and we're going to apply term document matrix, again, another function of the TM package, to the corpus that we created. Once we do that, it basically goes through and it counts the number of times each unique word shows up, and so that we can look at the results, and we can look at the results by using inspect, another part of the TM package. And what we're inspecting is the term document matrix that we created in the earlier part. And when you do that, you'll see that you get a list of all of the words that are in the sentences that we loaded up into the matrix. And it's not terribly exciting, but what it does is it shows you kind of just some general results, things like the sparsity and the minimal term length and stuff like that. But it just shows you, for every word that shows up, it tells you how many times that word showed up. Actually, it doesn't. It tells you whether or not that word showed up in one document, document 1, document 2, or document 3. That is the first, second, or third sentence. One thing you'll notice, a couple things you'll notice. One, notice the use of capital letters in some of the functions. That's something we don't typically see. So be careful when you're replicating this, if you decide you want to play around with it, because that case sensitivity is profound. And the other thing you'll notice is that the word is in your output is missing. There's some basic removal of words that's done even at this level, where we pull out common words that aren't useful. And it's a very short list at this stage, but it knows to pull out the word is, because that's not terribly useful. The next thing we're going to do is we're going to create basically a bag of words. So we're going to look at another example, and you'll see that in the second example, I have created something that looks similar, but instead of there being 3 sentences in the matrix, there are 4 sentences in the matrix. So we'll look at the first one, which is, this is the first, and then there's a big long space, sentence followed by 2 exclamations. You'll see that that's followed by, this is a second sentence, followed by a emoticon, or a lame attempt at an emoticon. Then you've got the third one, the third sentence is here with a comma in it. So this is, and a colon, this is filled with punctuation. These 4 examples are filled with punctuation. And the last piece is fourth of all sentence. Okay. So we basically run the same thing on this. So what we'll do is we'll set it up as a corpus using the corpus command. We'll drop that into corp. And that's basically saying, okay, it's a vector source, and the vector source is text, which is what we have up here. And so we'll drop that into a corpus. Then we'll do the TDM, the term document matrix, on corp, and we'll look at the results. When you look at the results, you'll see that it does basically the same thing, but now we're getting a whole lot of instances of something that basically looks like the same word. So we have, the indication of, in our 4 documents, we have the indication of where each word shows up. And we also have an indication of the fact that there's sentence with a double exclamation mark, and sentence with a comma, and then the word sentences. All 4 show up. So we're not quite to the token stage yet. Because when we get to the token stage, all 4 of those instances of sentence with the punctuation and with the S, that would be represented by a single token. And we might look at some of these other words, such as the and this and all, and even here, and say those are not tokenable words. They're not useful words. They're words that show up in any English sentence no matter what. So we're going to need to go through and start kind of cleaning this up again. So we're going to go to the tokenization stage. And here's where we get to a place where we're going to create tokens. And we're going to get rid of all the useless words and come up with just stuff that we think is useful. So the first thing we do is we come through down in this section right here. We've got our same corpus. We're just going to basically replace this corpus each time we run these commands. So this corpus is replaced using a TM map, which is basically text mining map. And it's a text mining map function, and we have to tell it what we want. We're going to text mining map the corp as it stands today, and we're going to strip out all the white space. So that goes away. Boom, that's cleaned up. Okay, and then that gets dropped into corp. So in the next command, we use corp again. That's the new corp that we just created. And we're going to remove all the punctuation. So that gets dropped in. So finally, we've got 3 instances. In these 2 lines alone, we have 3 instances of corp. We have what came in as corp, then we converted it to another temporary space, and then we convert it to another final space without any punctuation or white space. Then we can go through and do the same text document matrix of corp and the same inspect. This time when we do it, we come up with a list of all words that are truly unique. The words like all, first, fourth, here, second, sentence, sentences, the, third, and this. You'll see that a lot of them dropped out because the punctuation was removed, and that once we removed the punctuation, we created duplicates, and we don't want to ever have any duplicates in a list of tokens. But we still also have some words in here that are not useful. The words all, here, sentences represented twice, the and this, are all non-tokenable words. So we're going to go ahead and pull those out. So there's one last step here, and that's where the Snowball Library comes in. Make sure you go ahead and do an install package on that before you load this. But this is what we're going to use to strip out all of what we call stop words. Stop words, and there's a list of them, a short list of them, on page 485 of your textbook. That is a list of things that basically could show up in any English sentence, and they don't really hold a lot of unique meaning. So, and apparently there's a whole bucket of them. What they show on page 485 is just a small sample. And so we're going to go through and we're going to take corp and we're going to TM underscore map it again. It's going to be the corp is going to be converted to, again, a new corp. What we're going to do is we're going to remove words. And the words we're going to remove are stop words, and then we're going to remove the stop words that are English. Okay? And then we're going to go through and we're going to do our last step where we take corp. We set it equal to TM underscore map corp. And this is a stem document. What does stem do? Stem will take words that are similar. And in this instance, it's sentence and sentences. And it will go through and it will find a unique stem that they both share. So, and in this case, it gives you a sentence all the way up to the C. I don't know why it doesn't do sentence all the way to the E since they both share the E, but it goes through and finds that particular token, which represents both sentence and sentences. And that's what stemming does. Stemming it identifies the stem of common words. All right, we're down to our last bit here where we do the text document or the text document matrix on corp, and when we drop it out, we see that we get only 5 words. From all those words that we have only now 5 words, and they are first, fourth, second sentence, the stemmed sentence that goes S, E, N, T, E, and C, and then the last word is third. That is our list of tokens that came from our original 4 sentences. So this is a pretty straightforward script. I think it's got a lot of functions in it that we've not seen before, but I think they're easy to understand what they do. So here's what your assignment is. Your assignment is just you can go ahead and run through this script. There's nothing magical about it. Make sure you download the packages if you don't already have them, and then the library commands will work. And then you're going to go through and you're going to change the script up. And the way you're going to change the script up is that you're going to take, probably in the second instance, this first instance only has the 3 sentences that are loaded into the matrix. And that can just sort of remain as it is. Start here, and text will be loaded up with a matrix that has 5 sentences. And I want you to come up with those 5 sentences. You decide what they are. And then I want you to work through the rest of the script and see if you can get it down to a list of tokens that are truly unique and truly significant. It should remove all the stop words, it should remove all the punctuation, all the white space, and it should stem any words that are common or similar down to a single stem. And it just so happens that your instructions are down here. So here is your assignment for this week, this week. And then you're to change the input vector to have 5 different sentences. You pick the sentences. Don't just add a 5th sentence. I want 5 brand new sentences. Run all 4, I should say, run all 3 parts of the script. That's not important to run the first part because the first part really doesn't do much. Actually, let me make sure that I don't want to tell you something that isn't true. Let's see, we set text, we set corp. Yeah, I don't think it does anything that's unique. Okay, so the second part is to create tokens out of your 5 sentences. Turn the script with the final output when you have reduced your 5 sentences to a list of tokens. Next week we'll look at applying text mining to a real-world example. And by the way, these 5 sentences look like 5 usable sentences. So they could be the sentences that you use, or you could use something completely different. So what I want you to do is come up with 5 sentences and run them from part 2 of the script all the way to the end, and then show me what your list of tokens turns out to be. Let me know if you have any questions. Thanks.